This week we're going to use MetPy's new K-index calculation to evaluate thunderstorm potential over several days at a given upper air station. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I wanted to look at one of the new calculations that's in the most recent release of MetPy, which is the K-index. So first, what is the K-index? Well, the K-index is a measure of the probability or potential of thunderstorm development. So it's not strictly a probability, as you'll see. In fact, it's calculated, and this is a good example of how to use Markdown and LaTeX formatting in the notebook here. K is equal to the temperature at the 850 hectopascal level minus temperature at the 500 hectopascal level plus the dew point at 850 minus the dew point depression, which, remember, dew point depression would be temperature minus dew point at the 700 hectopascal level. So there's our formula. Now, of course, these generally are going to be reported in about every sounding you get, and we'll see there are some exceptions. I did find an unfortunate station who had a very limited set of dew points and several observations that I was interested in. Now, we can always use something like log interpolate 1D to fill in missing observations, but if the sensor just stops working very early in the ascent of the balloon, there's really nothing we can do. We can't extrapolate the dew point. So the first thing I'm going to do is from datetime, I'm going to import datetime. And we're going to use that to create the date that we want to get our sounding data from. So we're going to go 2021, December 11th. You remember December 10th and 11th, there was a pretty large severe thunderstorm outbreak. Station, we're going to look at the BMX station. And now we need to do some imports from MetPy and Siphon so we can get some data and work with it. So for metpy.units, I'm going to import units, and we're going to import the pandas data frame to unit arrays helper. Import metpy.calc as mpcalc. And from siphon.simplewebservice.wyoming, I'm going to import the Wyoming upper air object. Now we can get our data using the Wyoming upper air object's request data method. Given our date and station. And if we look at the head of that data frame, we see the standard fields that we'd expect: temperature, height, dew point, pressure, and so on. Now we do need to turn this into united arrays, which currently we do with our own helper. And that lets it work with MetPy's calculations. So now let's calculate the K-index. mpcalc.kindex. This simply takes a pressure sequence, the corresponding temperature, and the dew point. Those are all that's in our formula. In this case, we get back 26.29 or 26.3 degrees Celsius. We generally don't think of the K-index as having units, but it is just addition and subtraction of temperatures, so temperatures it is. Now, when we're looking at the value, there's a lot of guidance on what this means, like any index. Some would say that if K is 40, that is the best potential for thunderstorms with a lot of rain. Over 30, there's potential for a lot of thunderstorms. And below 30, thunderstorms are possible. And actually, below 30 is where a lot of severe weather happens because of the stability. If you think about where the dew point depression is in this equation, the Weather Service has a pretty interesting little note about this. Now, there are other scales that I found that say under 20, you really don't have anything to worry about. 20 to 25 would be an isolated thunderstorm. 26 to 30 would be widely scattered. 31 to 35 would be scattered. And above 35 would be numerous. So this would put us in the widely scattered thunderstorms category, and it's below 30, so we would expect that there might be enough instability for some of these to become severe. All right, well, that's just one calculation. What if we wanted to look at a time series? We've done maps before with other indices, so we're not going to make another map. But in this case, I want to make a time series of the K-index for this station for several days so I can watch these different systems pass through. For this, I'm going to make a function, get K-index. That's going to take a date and a station. And it's simply going to be these commands to get the data. And next, what do we need to do? We need to make it united arrays. And then we need to return the K-index calculation. So it's not a terribly exciting function. Going to import pandas as PD. And of course, import matplotlib. .pyplot is PLT, since we're going to make some plots. And I want a range of dates. In this case, I want to go from 0Z on December 1st up till 12Z on December 15th and do every 12 hours so I get the 0 and the 12Z sounding. Easiest way to do this is to use pandas date range function. We're using date range, the start, which you don't have to specify these keywords. I think in this case it makes the function call more readable, especially when you have to go back and maintain this in a few months. Okay, so we're starting December 1st at 0Z. End, date time, December 15th, 12Z. And the frequency is every 12 hours. We specify that with a string for pandas date range. Now we can calculate the K-index values. I'm going to use a list comprehension for this. Great example of where these save you a couple lines. We'll just keep our station from before. So that says for every date in the dates list, we're going to call get K-index, and then we're going to append that to a new list that at the end will be called K-index values. Now, this line will take just a little bit to run. While it's doing that, we can go ahead and write the code for our plot. I'm going to create a figure and an axis object using plot.subplots. And I'm going to specify that I want my figure to be 12 wide and 2 tall, so a very long, squat aspect ratio here, just because that's going to look good for this extended time series. And it looks like our data have already returned. I'm going to scatter with dates on the X and K-index values on the Y. I'm going to put a horizontal line at Y equals 20, and we'll make that a black line, just because pretty much everything that I have found agreed that below 20 there's really no significant thunderstorm potential at all, not even for isolated. So if the point is below the line, we're not that interested in it. If it's above the line, it could be a thunderstorm day for this region. And we're going to set the Y label to read K-index. And there we have our time series plot. So we see an early December thunderstorm potential. Then we see moving another one right here before the major outbreak. And then increasing K-index values up just through the outbreak. The outbreak was north of this station by a decent ways. So we would expect to see some reflection of the weather system moving through, but not necessarily that the outbreak is going to happen here. And of course, this is just an index. I hope that you found this useful, and I'll see you on next week's MetPy Monday.